Good morning, everybody. Today we're going to talk about how to write and solve a proportion. So we learned what proportions were and how to solve them yesterday. What we're going to be focusing on is writing them so we can use proportions to solve real life situations where things are proportional. So we're going to get into a bunch of examples. The only heads up I'm going to give you right at the beginning is that there's a lot of different ways to write proportions. Okay, we saw when we're running ratios, there's a lot of different ratios you can be writing in a situation. Part to part to whole, lots of different ways to arrange it. The thing to make sure that we are doing is that we're keeping our units in the ratio consistent. So there's more than one way to write it, and there's even more than one correct way to write it. But we just need to be consistent between the ratios and our proportion. And you'll see what I mean by that as we go through some examples. Okay, so let's start with this one. Mel can decorate 8 t-shirts in 3 hours. At this rate, write and solve a proportion to find the time it will take him to decorate 20 t-shirts. Okay, so the thing that we know, okay, and this is a pretty common setup for a proportion problem, we're given one ratio and half of another ratio. So we want to find the time it'll take to decorate 20 t-shirts. Okay, so the rate that I'm given is 8 t-shirts in 3 hours. So I can start by writing that down. So I got 8 shirts in 3 hours. Okay, I'm not going to write down the units here necessarily, but I need to remember that 8 stands for the number of shirts, 3 stands for the number of hours, because when I get to the next proportion, the next ratio, I got to write it the same way. If this was shirts to hours, this one also has to be shirts to hours. Right? If I mix it up, then this isn't going to be a true proportion. So because I had shirts on top here, I have to have shirts on top here. Okay, well, I know I'm looking for how long it'll take to do 20 shirts. Okay, the time that will take is the thing that I don't know. So we have time on bottom. I don't know how long it'll take to do 20 shirts. So that's where I'm going to put my variable. Let's put X. Okay, you can put H for hours or whatever you want to do. Okay, so here I have it set up. Shirts to hours. This is also shirts to hours. If I decided from the beginning to do hours to shirts and said 3 to 8, that's fine. I would have just had to set this up hours to shirts as well, in which case we would have had the X on top and the 20 on bottom. Okay, so this proportion would still work if it was flipped upside down, which hopefully makes sense given how we're solving it with the cross products. Okay, but we have to be consistent. If I did 8 to 3 equals X to 20, and had shirts to hours and hours to shirts, that's not going to work. So it's got to be consistent, it's got to be the same between the two ratios. Once it is, I can go ahead and solve. I do 8 times x is 8x. 3 times 20 is 60. Okay, then I do my train tracks. I'm going to get the x by itself, so I divide by 8. I get x equals 7.5. Okay, so 7.5 hours is my answer. All right, next one. So Adrian can decorate 5 t-shirts in 2 hours. So here's a similar one. So let's try setting up the other way just to make sure it still works. So let me do hours per shirt in this case. So 2 hours on top gives me 5 t-shirts. Okay, so this is a ratio of hours to shirts. Okay, so at this rate means it's proportional, means I'm using the same rate or the same ratio. Write and solve a proportion to find the time it'll take to decorate 18 t-shirts. Okay, so the thing that I'm given is the number of t-shirts, which in this case is number on the bottom. Okay, 5 t-shirts on the bottom, 18 t-shirts on the bottom over here. Okay. And what I want to do is I want to find the time that'll take. So let's do t for time. Okay, so I can solve it the same way. 5 times t is 5t. 2 times 18 is 36. Do my train tracks. Solve that for t. I got to divide by 5. That gives me t equals equals 7.2. Okay, and this is in hours because that was in hours. 7.2 hours is how long I can expect that to take. All right, so get another one. All right, so recipe calls for 10, serves 10 people, calls for 3 cups of flour. I want to make the recipe for 15 people and want to know how much flour I should use. Okay, so we're at my first ratio, 10 people to 3 cups of flour. Okay, I got people on top, cups of flour on bottom. I got to do the same thing over here. So 15 is the number of people, which go on top. Number of hours goes, or the amount of flour goes on bottom. Let's do F for flour. I'm trying to figure out how much that is. Okay. All right, so solve it the same way. 10 times F is 10F. 3 times 15 is 45. By train tracks, divided by 10. It's nice. Divided by 10 is always nice. Okay, 45 divided by 10, I know is 4.5. Yeah, that's going to be measured in cups because the 3 was measured in cups. So I need 4.5 cups of flour. Okay. All right, why don't you try this one on your own? So pause the video here, see if you can come up with this one yourself. All right, so hopefully this is the answer. You got 7.5 cups. Okay, setting up the recipe. I did people to sugar, so that's 12 to 5. Okay, it's 18 people over here, so 18 to X, because the amount of sugar I need, I don't know, that should say want, not want. Okay. So cross multiplying, I get 12X equals 90. Divided by 12 gives me 7.5. Okay. You might have also noticed 18 is just, to get from 12 to 18, you're multiplying by 1.5. Right? 18 is 12 plus another half. When you take 5 and another half of 5, that gives you 7.5. That's one you might have possibly been able to use your proportional reasoning on. All right, let's look at this one. Tom bought 3 pounds of apples for $11.97. So I got pounds of apples on top, price on bottom. Okay, how much would he pay for 5 pounds of the same rate? So I know the pounds of apples now is 5. Here I want to know the price. I'll put P for price. Okay, so solve the same way. 3P equals 5 times 11.97, which is 59.85. Divide both sides by 3. Okay, this might be a really good one to be using a calculator on. Otherwise, I'm getting 1995. Okay, so it costs 1995. You can check that, but I'm pretty sure that's right. 1995 for 5 pounds of apples. Okay. All right, so I'm going to pause this one so you can come with this one on your own. All right, welcome back. Hopefully these are the answers that you got. We got 17.94 for 6 pounds, 29.90 for 10 pounds. Okay. So we set up our proportion 4 to 11.96 in both cases. This is pounds per in the price. And then we had 6 pounds per in the price, 10 pounds in the price. Now another way that you might be doing this, and this is fine, is you might be using unit rates to find this. Okay. So you might have saw, well, 11.96 for 4 pounds, figured out the price per pound, which would be $2.99, and then just multiply that by 6 to get this number, multiply by 10 to get this number. Yeah, that is totally an acceptable way to do this. What that amounts to is simplifying this fraction and then doing the multiplying. Okay, that is an okay way to do it. All right, let's look at this one. There are 5 right-handed people and 15 left-handed people. If there are, let's say, for every 15 left-handed people, If there are 30 people in the classroom, write and solve a proportion to predict the number of students that will be right-handed. Now, this is one that we want to be careful about. Okay, our initial thought might be to do 5 to 15 because that's the ratio that tells us. Okay, right-handed people to left-handed people. Okay. But when I look at the information we're given, we're told how many people there are total, and we're looking for the number of right-handed people. Okay, so my proportion the ratio that I'm trying to solve here is going to be right-handed people to total people. Okay, so I don't want this right-handed people to left-handed people. Okay, I want to change it. So sometimes it's useful to write the second ratio first, the one that involves the thing we're trying to find. Okay, so the number of right-handed people, let's say that's R, to the number of total people, which is 30. Okay, then I can use this information to come up with a ratio that matches. So 5 right-handed people to 15 left-handed people. The number of right-handed people in that situation is 5. The number of total people would be 20. Okay, 5 plus 15, that's 20 people total. Okay. All right. So 5 to 20 equals R to 30. We can cross multiply to solve. R times 20 is 20R. Equals 5 times 30, which is 150. To solve this, I'm dividing by 20. And I get 7.5. All right, now another thing to keep in mind here is, does this answer make sense? Let's go back and says, we're writing and solving a proportion to predict the number of students that will be right-handed. Again, the number of students. If I ask you how many students you think will be right-handed, and you say 7.5, you're going to be wrong, because there's no way for half of a student to be right-handed. Okay, so 7.5 doesn't make sense for a number of students. So this is a situation where, based on what it's asking, we need to round it off. Okay, so 7.8, if I round this to the nearest whole number, 0.5 means I round up. We could say 8 people. Okay, so you might guess 8. Okay, you might also guess 7. It's just as close to 7. But following our rounding rules, we would round that up to 8 people. Okay, so a good guess would be 8 students will be right-handed. Guessing 7.5 is not a good guess, because that's not a possible answer. All right. There are some in your homework like this. I just wanted to look at least one example that looks like this with a table to make sure you know what to do. Okay. So here we have a table relating the weights of how much something weighs on different planets. So if something weighs 120 pounds on Earth, because of the different gravities, it's going to weigh 54.6 pounds on Mars, this on Saturn, and this on Neptune. Okay, so what we're given here is we're given a weight that it has on one planet, and has to find the weight that it would weigh on the other planet. Okay, so this right here is going to give us the ratio that has our unknown in it. Okay, so I can just write it just as is. Okay, so if something is 80 pounds on Earth and X pounds on Saturn, okay, the ratio between the weight on Earth to the weight on Saturn is 80 to X. Well, it's going to have the same ratio because it's comparing the same two gravities as it is in the table. Okay, so I just got to keep it consistent. This will tell me what values to pull from the table. So this is Earth to Saturn. So in the top, I'm going to pull the Earth weight first on top and the Saturn weight on bottom. Okay, so the Earth weight here is 120 pounds. Okay, the Saturn weight is 112.4. Okay. All right, now before I even start this, if I use my proportional reasoning, the top here is just a little bit bigger than the bottom, so I should expect the same here. So I should expect an answer that's just a little less than 80. If I get something that's way smaller than 80, or something that's above 80, I know I made a mistake, right? So for these to be proportional, if the top is a little bigger than the bottom here, that needs to be the same here. Okay, so if I multiply here, I do 120 times x is 120x. And then 80 times 112.4 would be 8,992. Let's try that again. 8992. Then to solve that for x, I got to divide both sides by 120. And I get x equals about 74.9. Okay, it says round to nearest tenth. So that's 1 decimal point, so 74.9 pounds. And like I predicted, that's just a little less than 80. So that works. Okay, so when you come across this in your homework, you can use this as one of your ratios, okay, 80 to x, and then you just want to line up the values from the table so that's consistent. Okay, Earth to Saturn, Earth to Saturn. Okay, if you've done it Saturn to Earth, then this would be Saturn to Earth. If you were told Neptune and Mars, then you would have done Neptune and Mars. Okay, just keep it consistent with what the value on top represents and what the value on bottom represents. Okay? All right, make sure you're asking questions on this stuff. It's really easy to get lost in the wording here. So make sure you're asking if you have questions. Good luck.